Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and his brother Joel Chaiken. Seth, I think we don't see enough of your mouth.
Okay.
There you go. There you go.
Yeah. I'm staring at the problem.
Oh, that's cheating. We're not. I don't
I'm
like.
not supposed to.
I like to do the problem cold because that's how people who are watching this are going to do their SAT. If they already saw the question, that would be called cheating. Okay. So today this is an uncalculated section. Today we're going to do a problem that has two parts. Let's say there are actually two questions. So today you get 2 for 1. So I might as well do both in the same day. So we'll just focus in. See, it says questions 19 and 20 refer to the following information. So let's read the information. A sociologist chose 300 students at random from each of the two schools. Okay, there are two schools, and asked each student how many siblings he or she has. The results are shown in the table below. Okay, there are a total of 2,400 students in Lincoln High. So, yeah, might as well write that in, right? And then 3,300.
Is it?
Yeah.
You added them up?
No, there are a total of, Lincoln High is 2,400, and...
Is it?
Well, it says, yeah, right there. So we might as well add it to the thing. That way we don't have to, we can,
I know, but I added them up. I got 200 plus, I got 300 when I added them up.
Right, Lincoln. I know. That's because the study was 300.
Yeah.
I don't think we have to add. Well, it doesn't hurt to add them up.
I see. There were total. Oh, they say the total. Okay.
Right. Okay, great.
The
so
bottom, it says there's a total of 2,400 in the Lincoln and 3,300 in Washington. Okay.
Okay. What is the median number of siblings for all the students surveyed?
Oh.
Oh, my goodness.
For all the students surveyed. Oh.
Wow. Okay, so one thing. If you answer this question and you say 2, then you should know when you have a table question, you never answer a table question in 2 seconds or less. Okay, this is in general. This is a trick. You do not. A lot of people are going to say 2 because it's clearly the median, right? Right. So whenever you do a table question, if you're answering the question in 2 seconds or less, you're doing it wrong. You're probably doing it wrong. They can make a trick and they can make it so that.
Okay, notice it's about, it refers to the students surveyed.
Yeah, right, which means...
And so the 2,400 and 3,300 data are irrelevant to this question.
Absolutely correct. Absolutely correct. So, the calculator work certainly helps here.
Yeah.
So...
What are those funny numbers on the right?
These are the sum. The sum, because it's the total students surveyed. So you have to sum 120 and 240 to get 260 because we're going to need that number.
So 260 is what? The number of students, the number of surveyed students in the two schools together who have 0 siblings.
That's right. They're also called the only child.
Etc. Right,
Only called the only child. No. The only child is 1. Sorry. No children is this.
0 siblings.
0 siblings.
One sibling, 2 siblings, etc.
Yeah. Surprised it didn't have anything greater than 4, but whatever. So, okay. Now, how do you get the median? Be careful. So, it looks like a very long problem, right? Because
I think of this way. You start adding up from the bottom. Oh, I'm sorry. I'm moving it around.
That's okay.
You start adding up from the bottom. Get 0. Boop, 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 boop. 20. Boop, 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 boop. 60. What's 6 and 9? 15?
15.
Beep, 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 beep. 1,500. Oh, wow.
Yeah, but you have a calculator.
This is one of these questions where they made it up to be a round number. Okay. The number of no, we're not yet. The total number of students is 600, and I'm nowhere near half of 600. So I keep going, boop, boop, boop. Say 150 and 190 makes what, 300 something?
340.
340. and 340 is about 10% more than half of 600. So the median is around here, right? Somewhere around here. And so I guess the answer, and they're looking for a round number answer. And so I guess it's 1.
So they were
Right?
600. So what census says, first of all, what is the median? The median is the middle number. The
Yeah.
middle number. The middle number. Now there are 24s. There are 24s.
Well,
Okay.
we don't see. The thing is this, the 20 here. The 20 here stands for, say, if you line up all the students with 4 siblings. Beep, beep, beep,
No, actually,
beep,
wait,
beep,
I made a
beep,
mistake.
beep,
I made a
beep,
mistake.
beep, 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 beep. We get 20 students.
We started. Wait. We got to start at we start at 0. With 0.
Oh, I could start with 4. I don't care.
No. We always start at the
All
low
right,
number.
you want to start at 0? All right, so I can
that
start
means
at
there
0.
are 260 slots here. There are
Yeah,
260.
so therefore, if I wanted to start at 0, I'll use a different color.
So that's okay. I'm doing
starting at 0, here I have 0. And then I go beep, 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 beep.
So I'm doing it down
260.
here. I'm doing it down here.
Yeah.
Right. Okay. And then
I'm doing it right next to the chart because it's already printed.
Good idea. Now, so 260 zeros. Now we go 110 more to 390.
Yeah.
Which is here. And that's how many there are. 1. There's a 1 here, okay? We'll put it at maybe a bigger font. 1 sibling, right? And you know that the total is 600 total, right? 600. So the middle number is in the 300th. But this is already 390, so the middle number is here, right? 300. So that clearly it's a 1.
Yeah.
Very good, sir. You got it
right. Yeah, so 1 fits in the middle.
Yeah, so 1, you see how we do it? See how we have to line them up? We have to multiply. We have to distribute those 0 260 times.
Yeah.
Right? And we have to distribute these many number of times.
Yeah.
This is classic. This is a classic question. This is asked so many times.
Yeah.
So you have to know what the median is, and you have to be extremely careful not to say 2.
Yeah, I think it's exactly 1. Yeah, The idea is to sort of line up like do it this way. On the left-hand side, start on the left-hand side, and the first student we put in the line. I'm going to write the number of siblings that first student has. Then, I'm sorry, I made a mistake. Did you erase it?
No.
No, okay. So I'm going to put a 0 right here for the number of siblings that the first student in the line has.
Right.
Put another 0 for the number of siblings the second student has. And then I'm going to imagine.
Oh, I see. Wait. We have
20. I'm going to imagine 20 students. The total of 260 students, all of whom are represented by a 0.
Yeah.
Because they have 0 siblings.
Right.
And then I'm going to start writing 1s.
Right. You have 260
to
zeros.
represent the marks, represents the students who have exactly 1 sibling,
right.
And the number of those is 190. So it's 190. 80 plus 110 is 190. So I imagine a row of 191s.
Right.
Right? And now, if I count off 1, 2, 3, 260, 261, 262, 263, this one is going to be at position 350. So I get 261, 262, blah, 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 290, 291, 292, 293, 300.
450. We all made mistakes. I was wrong here.
The 300.
I was wrong here.
The 300 student is in this position, and that student has one sibling.
Right. You basically line up. Well, you have 260 zeros. You have another 190 ones, and then you go from there. But Seth's insight was very good. That the total is half of the thing is 300. Notice I wrote this 390. That's completely wrong. I don't know where I got 390 from. I could rewatch the video and see where my mistake. And Seth actually wrote 350 when it's really 450. So we both made stupid mistakes, but we still were lucky enough to get the right answer.
No, I counted up from the bottom. Did I? Oh.
Yeah, it's 450.
It is 450?
260 plus 190 is 450.
Yeah.
Yeah, we all make carrying mistakes. But anyway, notice we both made mistakes, but we still got the right answer. But Seth had the good insight.
Okay.
Okay,
good.
so we got enough of that. You have to know what the median is. The middle number. Whenever you see table question, you do not answer it in 2 seconds. If you answer in 2 seconds, you're probably wrong. Because the answer is not the obvious 2.
Yeah.
I can't tell you how many people are going to say 2. Be careful, but learn from your mistakes. Don't do that. Okay, right. Number 20. This is the first time we've ever done, well, maybe not the first time we ever did 2 questions, but this is our first double tandem question we've done. Congratulations. Okay, based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? Oh my God, too many numbers here. It compares the expected total number of students with 4 siblings at the 2 schools. Okay. The total number of students with 4 siblings is expected to be equal to 2 schools.
At the schools.
Now remember, when you do this, you don't answer. You answer the best answer, not an answer. You have to look at all of them. The total number of students with 4 siblings at Lincoln School. What? Is expected to be 30 more? What is that? Ooh. That's weird. The total number of students with 4 siblings at Washington. What? Where did they get the 30? Where did they even get that number 30 from? I don't know. The total number of students with 4 siblings at Washington schools. What?
At the 2.
That's those answers from B, C, and D, or where did they even come up with those? Isn't it A?
Well, let me read them. Read them. Choice A. So these are statements, and we want to choose the statement that is most accurate. So statement 1. The total number of students with 4 siblings is expected to be equal at the 2 schools. Okay, let's keep that in the brain. I don't know. Second, I don't know yet. I have to. It has to come to me.
That's right.
Question 2. Choice 2. The total number of students with 4 siblings at Lincoln is expected to be 30 more than at Washington. Okay. The total number of students with 4 siblings at Washington is expected to be 30 more than at Lincoln.
I made a mistake.
Okay. And the fourth is the total number of 4 siblings at Washington is expected to be 900 more than at Lincoln. Okay. So what I think what's going on here.
I made a mistake. I'm wrong.
I think what's going on here is they want you to use the samples.
Right. Yeah.
At the 2, use the samples at the 2 schools separately.
Right.
To find to calculate an estimate. Right.
Yeah.
Of the frequency of numbers of siblings.
Yeah.
In each school separately.
Yeah.
And then once we find the estimated frequency, which could be called the probability.
Right.
Once we find the probability that a student in Lincoln has 4 siblings, we'll get some probability. We multiply that probability by the total number of students in Lincoln to get the expected number of students at Lincoln with 4 siblings.
Right.
And that's going to be some number, right?
Yeah.
And then we do the same thing with Washington. Okay.
1/30th of 20.
So the first step in this problem is to calculate the sample frequency for 4 students in first Lincoln and second Washington.
Right.
So that sample frequency for Lincoln is 10. Okay, for Lincoln, I'll do it for Lincoln.
Jeff, I already did it.
You did it? Oh,
yeah,
I
did it. It's there. It's 1/30th.
Oh, it's such a mess.
Yeah. Okay.
1/300th. What?
No, 1/30th.
No. 4 siblings. 4 siblings.
Seth, it's right here.
4 siblings at Lincoln is 10 over 30.
Right. No, 10 over 300.
Oh, you're right. Yeah, I'm sorry, 10 over 300.
Right,
so this is the probability. 10 over 300.
Right.
Is the probability, is the frequency, and then we're going to use this frequency as the overall probability of having 4 siblings. If you're in Lincoln, to get the expected number, we multiply that by 2,400, which is the total number in Lincoln. So the expected number, so say E in Lincoln, number of siblings equals 4, is equal to 1/300th times what? 2,400.
Times 2,400, right.
2,400. For the corresponding number for Washington, its number of siblings equals 4. Let's see, it's 10. It's also 10 over 300.
Yeah,
so
the
frequency is the same, but this time but Washington has many more students, 3,300. Okay, so the expected number is in Washington is expected to be bigger. Is it 300 more or 900 more? Oh, you figured out. You figure. So I don't know. We cancel out the 1/3. Cancel out the zeros. 1/3 of.
You didn't give yourself enough space. You can't even
they'll give
read
you
your own rating.
1/300. Well, it's 1/30th. I'm sorry. It's 10 over 300. So it's 1/30th. 1/30th
now,
of 3,300.
People have a calculator. Everyone has a calculator.
And you can use a calculator. All right, use a calculator. But 1/30th of 3,300 is 1/3 of 330, which is 110.
Right.
And 1/30th of 2,400 is 1/3 of 240, which is 80.
Right.
And the difference is 30. So that's the difference is 30 with Washington having more. And so we get to choice C. All right.
Yeah, I feel really bad.
So this is a question about how to draw statistical inferences from a sample, and then use the inferred probability of something, like in this problem, the probability that the kid chosen randomly from the school has 4 siblings, and then calculate the expected number of kids with 4 siblings, which an expected number of it's the total number in the sample times the probability.
Basically, you're extrapolating. You're extrapolating from the sample. 1 out of every 30 kids is a 4-person family. If you have 2,400 kids, and 1 out of 30 of them is a 4-person family, but you have 2,400, that means that you have 80 kids that have a 4. The prediction is that you will have about 80 kids. And similarly, if 1 out of 30 of a 3,300 person school has 4 kids, then you extrapolate out to 3,300. Yeah, right. Now, of course, I feel like a jerk and a fool because I would have gotten this question wrong. I did it too fast. Did you notice? Like I said, I read it too fast and I wasn't thinking. And it did occur to me when I was thinking this, saying, well, if I answered A, then I'm not using this information at all. And it did occur to me, and that made me feel a little uncomfortable.
Yeah.
But then when Seth read it more carefully, I realized I made a mistake, as you saw. So the lesson I would take from this is if you're not using a piece of information on the SAT, there's about a 90% chance of doing the question wrong. We actually saw a problem above, remember? We did a problem where they gave us extra information which we didn't use. But it's rare. It's rare.
Yeah,
it's rare.
yeah.
So this should have been a dead giveaway. No matter how confident I was, a little cocky, which is you're cocky, you're gonna get a question wrong. And then we kill that cockiness. Right? I mean, I should have been more humble, and I should have realized.
Yeah, I have to read it all very carefully. Yeah. Well, well, I think there's a piece of the question that's confusing.
Mm-hmm.
The top of the introduction to the question says is about comparing the expected total number of students with 4 siblings at the 2 schools.
Right.
The word "total" throws one off, and I think it shouldn't even be there. So I saw this, and I couldn't make any sense about how to answer a question, whether to answer that question. Well, I saw this about total, and then I started reading about the 2 schools, and I used the statements all by themselves. I threw out of my thinking the introductory topic of the question because, frankly, I think it's ambiguous.
Okay.
However, the structure of the question is there are 4 specific statements, and your job is to choose the one that is most accurate.
Right.
Based on the information in the table.
Sure.
Right. And so, based on the information in the table plus the data about the totals.
Right.
Okay. What they're actually doing is comparing the expected number of students with 4 siblings at one school with the expected number, not total, but number of students with 4 siblings at the other school.
Right.
So this total word, I think that's a bug in the problem.
I mean, I don't know. The way I read it, you saw the way I misread it. I misread it as the probability. Really, what's the compare the probability?
Yeah, that's what it is. That's what the particular statements are about.
Right. Yeah. So I answered compare the probability of one school to the other, but that's not what they were asking. They were asking the total number of students. Wow. Yeah.
Well, they're not asking the total number. They're saying they will ask about the expected total number. And then the statements are not about the total number in the 2 schools, but about the number with 4 siblings at each school, and then to compare those numbers.
Wow, you're reading it. You're like really reading it
like a lawyer and a mathematician would.
Okay, watch out. Yeah. And I read it too fast. But you got it right. Congratulations. Okay. Wow. Statistics problems. You really got to watch yourself on statistics problems. But Khan Academy gives you a lot of practice with these statistics problems. And yeah, just read these statistics problems really carefully. And I fell into my own
Yeah.
mistake. I answered this question too fast. You see how
Yeah,
I?
yeah. Well, let me also say, when you see words, see statistics words like expected. That is a word. Not it does not mean in math and statistics and SATs. It does not mean, hey, you know what you expect to happen. You know, you go out in the winter, you expect it to be cold.
Yeah.
You go out when it's raining, you expect to get wet. That is not what expected means in the SAT questions. Expected thing is a number, and it means specifically the probability of a certain situation times the total number of things with or without that situation. In other words, it's the probability times the size of the probability of a certain situation times the times the total. Right.
I mean,
So that's what expected means here. Now there's another form of expectation, and that is when
no,
we
that's the
ask
average. That's the
for the
weighted average.
expected
Weighted
number of
average.
siblings.
Okay.
Here they're asking for the expected number of students with 4 siblings.
Okay.
A related or another thing that might be expected is the expected number of siblings. That's different from the expected number of students with a
Right.
certain number of siblings. Is different from the expected number of siblings. Right?
Yeah. Right. Of
And
course.
this question does not ask about that.
Yeah. So let's not talk about it.
Yeah, yeah, that's a different thing. You should look, if you please find some other source about finding in a question like this what it means to find the expected number of siblings
Yeah.
among of four students in say one of the schools.
Right. Okay.
Right.
Yeah. Okay. Let's see. So what? Two comments. One you saw in red. If you do a problem too fast, it's very bad in stat stuff. Okay. If you're doing a problem too
Yeah.
fast, that's a warning that you're misreading it. I should have heeded my own warning. The other thing,
Yeah.
Seth, is come on. If what expected means expected. I mean,
Well,
expected. I mean, if a
no,
school
no, no.
Seth
It's
Seth
best to practice how it's used and applied and calculated in examples.
wait, just hold on a second. If you expect 10% of a school to have people with blonde hair, right? No, 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 no. As you do a study, let's say you're told 10% of the students in the school have blonde hair. Okay? Totals, men, girls, boys, whatever, right? And there are
10%, yeah.
100, there are 1,000 kids in the school. Can't you
Yeah.
simply say in English, well, I would expect there to be about
Nah.
100 kids with blonde hair? Why can't you use the word expect there? Why can't you say it? I would expect there would be about. Like, what's wrong with that? What other word would you use?
Well, you would say if 10% of the students in a school have blonde hair,
Right?
I could say I wouldn't expect to find very many students with blonde hair.
But you still use the word expect.
Yeah, yeah.
So I don't see the problem with using the word expect in like as if you're expecting
Yeah.
it to have you expect to go out for dinner tonight, you expect to be busy today.
Well, still, it's yeah. They don't give you could make there's some situations where and especially in probability where what you guess intuitively is wrong,
Well, yeah, of course. Of
and
course.
there's a whole lot of problems with that. And
Oh, okay.
Yeah,
Well, you
yeah.
you could expect something
That's a
that you would be
whole
wrong, right?
Yeah, there's a
Yeah,
whole
yeah,
literature on how to law how statistics are misleading,
right, yeah,
how to lie with statistics.
right,
That
right, right.
they Yeah, anyway. So
But
that's but these SAT questions, fortunately, in the modern version of the SAT, they're pretty unambiguous and straightforward.
right, that's true.
Yeah, they're pretty routine. And for those people who have been in school and picked up the routine knowledge and techniques and ways of thinking that they teach in school,
Right,
because it's a scholastic aptitude.
and the
And
Khan
you could
Academy,
develop your scholastic aptitude by, like, you could develop your sports at aptitude by practicing sports. You could develop your scholastic aptitude by practicing scholastics.
right, right, and Khan Academy really, really helps because Khan Academy is it basically has a close relationship with the SAT, and the
Hmm.
Khan Academy has set up questions that are really in line with the SAT. Plus, the SAT gives you 8 practice
Yeah,
tests.
yeah.
So,
Okay.
okay, great. So we killed this one. I think I
Yeah,
particularly I'm sort of reeking here in pain. Okay, so anyway, like us, dislike us, please give us comments, and if you have any math SAT questions you want us to go over, email us at SAT math question of the day at gmail.com. So
yeah.
anyway, have a great day, everyone. Bye bye.
Okay.
Bye.